So you know the drill, right? You're constantly battling firewalls, punching holes in your network, trying to manage these complex IP whitelists. It's a never-ending game of defense. Well, what if I told you there's a totally different way to think about securing your applications? A way that moves security from the edge and puts it right inside the app itself. Today, we're going to dive deep into the world of OpenZiti. Just think about this for a second. What if your apps didn't have to trust the network they're running on at all? What if they could literally build their own secure private internet, connecting only to the services they need and absolutely nothing else? That's the huge idea we're going to unpack today. All right, so how does OpenZiti actually make this happen? To really get why this is such a game changer, we first have to look at the way we've always done things. And, why that old model is really starting to show its age. For like decades, network security has been about building these digital fortresses with firewalls and gatekeepers like IP whitelists. But what if we could make our services completely invisible to begin with? That's the whole OpenZiti philosophy. Instead of trust but verify, it's never trust, always verify. As you can see on the right, your services become dark by default. That means zero open ports listening on the internet. The only way you can even see a service is if you've already been authenticated and authorized.
Now, I know what you might be thinking. Okay, this kind of sounds like a VPN, and you're not wrong. That's a great place to start. But to really understand OpenZiti, we've got to be clear on what it isn't.
So, a VPN, a virtual private network. We all know what this is. It's an amazing tool for creating a secure encrypted tunnel from point A to point B. It's basically like building a private secret hallway right through the middle of the public internet. Super useful. OpenZiti, on the other hand, is an overlay network, and this is a whole different beast. Think of it less like a single hallway and more like an entire, intelligent transportation system that you build on top of the existing internet. It has its own traffic rules, its own routes, its own policies, and it's all totally independent of the physical roads underneath. So let's just put it all side by side. A VPN is like a really good lock on a single door. It gives you a secure connection between two specific places. OpenZiti, though, is the entire building security and logistics system. It's not just about one secure tunnel. You can see here, it's about managing your entire application fabric, dynamically choosing the fastest path for performance, and giving you this incredible centralized control over everything. Okay, so the big question is, how on earth does it do all this? Well, the secret sauce is that it takes the whole idea of networking out of the infrastructure and puts it directly inside your application. And this question from Philip Griffiths at NetFoundry, man, it just nails it. This isn't about buying another box or adding another firewall rule. It's a fundamental shift in where the networking brain actually lives. This right here is their guiding principle, their North Star. By using an SDK to embed the network right into the app, the application itself becomes its own security perimeter. Think about that. It doesn't have to trust the server, the container, or whatever network it's running on because it brings its own private, secure network along with it. And hey, this isn't just some abstract theory. People are doing this right now. In Python, you can secure serverless functions in Lambda, making them totally invisible to the internet. For you Java folks, a single line of code can make an entire Spring Boot app go dark. They're even using it to lock down monitoring tools like Prometheus. It is incredibly flexible. Okay, so we've got this idea of an intelligent transportation system for our apps. But how does it know which route is actually the fastest? Let's pop the hood and look at how its smart routing actually works. It all comes down to a strategy called smart routing. The system is constantly looking at all the possible paths across its network, and for each one, it calculates a cost. Then, it just picks the path with the lowest total cost. Simple as that. So what goes into this cost? It's actually pretty straightforward. It looks at three things: the cost of each router along the way, the cost, and this is key, the real-time latency of the links between those routers, and finally, the cost of the destination itself, what they call the terminator. And here's a real example. The system takes the fixed cost of the link, adds in the live latency measurements, and calculates this total full cost on the fly. It's literally like a Waze or a Google Maps for your application's data, constantly finding the best route and automatically steering you around any traffic jams on the internet. Okay, so what happens when you put these two huge ideas together? You've got this app-embedded identity, plus this intelligent smart routing. Well, you start to unlock some seriously powerful new abilities. Let me show you a great real-world head-scratcher from a user on their community forums. They set up what's called a posture check, basically a rule saying a device must be on the corporate domain to connect. The check was failing, just like it was supposed to, but the user could still get to the server. What gives?
And here's the reveal. It all comes down to a crucial concept. In OpenZiti, policies are additive. That means if any policy says yes, you're in. The user probably had another, more general policy that was still letting them connect. It's a simple idea, but it's incredibly powerful. Access is denied by default, and you just add the permissions you need.
And this identity-first approach is what lets you do some amazing stuff. You can create those truly dark services that are just invisible to attackers. You can automatically route around major internet problems like BGP hijacks, keeping your apps online. And because every single connection is tied to a strong identity, you get this rich visibility into who is accessing what, from where, and when. It's incredible.
So where is all this headed? What does this really mean for the future of how we build and connect our apps?
You know, I think this quote from Dave, the project's co-founder, just brings it all home perfectly. It's like a service mesh which manages traffic between microservices, but for the entire internet. It's a secure, programmable network layer that you can embed literally anywhere. So, if you remember just 3 things from all this, make it these. 1, it's an overlay network, not just a VPN, which gives you total control. 2, the real magic is that it's application embedded. Security moves right inside your code. And 3, it's programmable and smart, using policies to drive not just access, but performance. And that really leaves us with one final massive question. If the network is no longer this separate, complicated thing we have to manage, but instead it's just a library you include in your code, what does that make possible? What new kinds of secure, resilient, and globally connected apps can we even start to dream up? The possibilities, well, they're pretty exciting to think about.